Okay, so now we're going to, we've taken a look at bootstrapping and we've done a series for LBM when one is clearly higher, bigger, greater than the other, and we have a positive CI, a positive confidence interval, the median distances. Let's take a look at something where we don't have that happen. So I've used height data, and I've split it into genders, male and female, and this is census at school data for height. And we'll take a look at medians, and this happens a little bit slowly on this, but you can see that we have now a sample, and we see that in our sample the medians are marked, and there's a distance in our sample between the male and the female. The females actually end up being a little bit taller in our sample than the males by about 2.5 centimeters in this particular case. So a little bit, the males are a little bit taller. Now remember, that's just one sample, and because of sample variability, we want to resample a lot from this one sample and see what happens when we resample a bunch of times. So we're going to do our 1,000 resampling, and we're going to take a look at what happens when for that distance between the medians when we resample 1,000 times. So we can see that the medians are changing, but what's more importantly is that you notice what's happening with this arrow. The arrow sometimes is pointing to the right, sometimes it's pointing to the left. Sometimes the difference is almost non-existent. Sometimes the distance is quite a bit. Sometimes it's positive, sometimes it's negative. So sometimes that arrow is going to the right and it's longer, shorter, different distances. Sometimes it's pointing to the left, which when it points to the left, that's suggesting that the males now tend to be taller than the females. So we have this confidence interval in the medians that is created. The males obviously have a lot more variability within their medians than the females, but you can see what's happening with the medians. They completely overlap. The females' medians completely overlap the males' medians for height. And we notice that the distances sometimes were positive, sometimes the females were taller, but sometimes it was going in the other direction, which means that the males were sometimes taller. Now, if we create a confidence interval of what's happening here and we interpret this, basically we're saying in some samples the males were taller, in some samples the females were taller. So if we do our bootstrap distribution and we drop those distances down and we make our distribution of these arrows, basically we just drop those arrows down very quickly. Sometimes they're going in left, sometimes they're going right. So sometimes the distance is positive, sometimes the distance is negative. And you can see what's happening with the distribution. The distribution now, some of it's the distances from 0 to 10 tends to be the maximum, but it also goes from 0 to -10. So there's some negative distances and some positive distances. And what that suggests is that sometimes the males are taller, sometimes the females are taller. Now when we show our CI, the confidence interval, those distances, from our sample we can see that the distance is about 2.5 and that females tend to be bigger from our sample. But the more important thing is the bootstrap confidence interval that is created, and it ranges from -6 to 8.5. Now, there's 0 in that confidence interval. That suggests that for some of the samples, males were taller. For some of the samples, females were taller. And because 0's within that confidence interval, that tells us that we can't really make a call back in the population that there's a difference in the heights between females and males. Because with that 0 there, what that tells us is that sometimes the males are taller, sometimes females are taller, sometimes there's no difference between these. So if 0 is within that confidence interval, we cannot say there is a difference in the heights of the males and females from the census at school data.